Hello, ladies and gentlemen. Here we are again. We are on Module 4, Lesson 7 on page 53 of our books, and we are working on markup and markdown problems. And you'll notice I have just one simple essential question there. How do you apply multiple discounts, right? It's that time of year when people are doing a lot of shopping for holidays or for different gifts for the holiday season. And so, this is the time of year that's really kind of appropriate for us to talk about this. So here we go. We have markups, markdowns, original price, selling price, and markup, markdown rate. All right, so we've got some vocab that we got to hit here. So markup, the definition of a markup is an increase in price. So this is what happens when the store buys an item from the seller and they have to mark up the price. They have to increase the price so that they can make a profit, right? So that they can pay for the electricity and they can pay for the salesperson and all the different things, the rent of their place, all those things. They have to mark up the price so that they can actually make a profit. So that's what markup is. Markdown, you probably are more familiar with. Markdown is the decrease in price. This is the discount. This is when they're telling you everything is 50% off in the store. And you're like, well, how can they make everything half price? Well, because they've already marked up the price, and then they can mark it down and still have a profit, but give you a discount, or at least what you think is a discount. All right, original price. Now this varies depending on the problem. It's the starting price before the markup or that markdown. So it could be the starting price that the store is getting it for, and then they're going to mark it up. Or if it's in a different story problem, it could be the markdown in which the store is selling you an item and they're telling you it's this price, and then they're going to give you a discount. So it just depends on the story problem as to what that starting price will be. All right, selling price. Again, this is going to vary depending on the problem. The starting price is the cost to you. Okay, so how much it's going to cost you when you walk out of the store, or it's the wholesale price, what the store is going to pay. All right, so when you see the word wholesale, it's what the store is buying that for to get it into their store as the product before the markup. Okay, so now to figure these two things up, the markup, markdown rate, there's two problems that you have to know, okay? Most of the time you're going to use these. The selling price is equal to 1 plus M, we're going to call that the markup, whatever that percent is, times the price. Okay, that's how they figure out the markup. You're going to add 1 to it. The 1 represents one whole, or 100%. We're going to pay, you have to pay 100% of the product plus the percent of that they're going to mark it up. All right, and then the markdown is found the other way. Selling price is equal to 1 minus that percent, right? So 1 minus 0.25, right? You pay 75%. You're saving 25%, but you pay 75%. All right, so if you need to, hit pause so that you can write all those down. I went through those kind of quickly, but these are all terms that we're going to be using throughout this whole lesson. All right, so if you are ready to move on, though, here we go. So Games Galore Superstore buys the latest video game at wholesale. So that means they're buying it, right? The manufacturer is selling it to them for $30. The markup rate, here we go, markup rate is 40%. You use your allowance to purchase the game at the store. How much will you pay? Not including tax, right? Your parents will pay the tax, you just have to pay. So we want to know, how much are you going to pay? So let's break down what we know. So we know that the wholesale price was $30. We also know that the markup, right? The markup, I'm just going to put an up arrow, is 40%. Well, we have to change that to a decimal, so 0.4 or 0.40. And so what we're going to do is we're going to plug that in to figure out how much you're going to have to pay now. Okay, the selling price. We're trying to find the selling price. How much is the store going to actually put on the ticket or on the sticker, or, the price tag? So the selling price is equal to the 40% plus or minus 1. Which is it? Yeah, plus 1, right? Because they're adding, this is a markup. So we're going to add 1 to it and then multiply it by the 30 that the store actually purchased it for. So technically, we have 1.4 times 30. So you grab your calculator and you find out that the selling price is how much? It's $42. Okay, we just did it all in this one spot, so it's going to cost $42 before tax. Okay, $42 on that price tag, and then they're going to add the tax onto it. We'll deal with the tax here in a little bit. By the way, continuing with this problem though, okay, what's the total markup of the video game? In other words, how much money did this store actually make off of you, right? So they're going to sell it, right, for 42. That's the selling price that we just calculated. And they bought it for 30, right? That's the wholesale. That's the wholesale price. So if I subtract these two, we get $12. That is the profit. That's how much the store made off of the actual game before they have to pay everybody. Okay? You and a friend are discussing markup rate, right? You both are in math class and you're like discussing how this works. Your friend says that an easier way to find the total markup is by multiplying the wholesale price by 40%. Do you agree with him? Why or why not? So here's what your friend is saying. Your friend is saying, let's take that 40%, 0.4, and multiply it by the wholesale rate, which was 30. And if you do that, you get 12. Well, the 12 is actually the profit, right? We know that those are both the same number. So your friend has figured out how much they're actually going to make, right? This is the profit. Your friend still has to do one more step, right? So this does work as long as you understand you have to then add that to the 30. 30 plus the 12 that you just found, right? To get you to the $42. So yes, your friend is right. This is true, but you do still have to add it to that final one to get the total amount that they're actually going to charge you. But if you're just trying to calculate how much money they made off of you, totally works. All right, so yeah, recently we had Black Friday, right? Where everything goes on sale and people stand out in line and stand out waiting to get that really good deal on something. Well, yeah, I am that crazy person. I actually do like to do that, or at least I used to when my kids were little. Don't do it as much anymore. But anyway, so it's Black Friday, right? A $300 mountain bike is discounted by 30%, right? So you're like, hey, 30% off, great. And you have a 10% off coupon for anybody who shows up before 5 a.m., right? You are there when the doors open. So I'm curious, what is the final sale price? So if you get there at, before 5 a.m. and you're doing this, how much money are you actually going to have to pay for this $300 bike? Well, let's talk about this first. So a 30% discount, right? 30% discount, I'm going to have to take 1 minus that 0.3 to figure out how much I'm really paying, and I'm going to multiply it by the $30 price, or $300 price, excuse me, right? $300. So technically, I have 0.7 times 300. All right? Well, 7 times 3 is 21. So this is going to be what? $210. That's if I just show up anytime on Black Friday. But if I get there early, I get an additional 10% off. So now I'm going to take this one here. That is now my new starting value. Okay, that's my new starting value. And I'm going to take an additional 10% off. So 1 minus that 10%, right, because there it is, times that $210 that I'm going to save just by being on Black Friday. And now that additional discount. So now I've got 0.9 times $210. And I am going to end up paying $189. Woohoo! That's not bad, right? That is not bad. All right, well, let's go. I'm going to skip over B because we kind of hit it twice, so I'm just going to hit it on the other page. So let's go over to C. After both discounts were taken, what was the real percent off? Now, most of us want to say, oh, well, 30 plus 10 is 40%, right? That's what most people think. Well, let's kind of do some analysis of this and see if it really is 40%. So we're going to kind of backtrack a little bit. We're going to go back to where we talk about the part and the whole. So we have our part that's $189, right? How much we're going to end up actually paying. The whole was $300, and the percent is our unknown. Okay, so we're kind of reviewing back to the last few lessons. So let's set this up. We have our 189 is equal to our percent that we don't know times the whole, which we know is 300. So if I divide by 300, 189 divided by 300 gives me a beautiful answer of 0.63, right? That is what my P is, or 63%. No, that is not what I saved. 63% is what I paid. Okay, this is how much the percent I paid. So I just need to subtract it from 100. So take 100 minus the 63. This is going to be how much of my discount. This is the discount. Okay, this is my discount. And so when I subtract that, I find out that I have 37% saved. That's my discount. Most people think it's going to be 40, and it's close to 40, but it really isn't, right? It's not quite 40%. Okay, so instead of purchasing the bike for $300, how much did you actually save? Not how much did you pay, but how much did you save if you bought it before 5 a.m.? So the bike would have been $300, right? But I saved, or I paid, excuse me, $189 for a savings of $111. Do you believe it's worth it to go then to the store and do this? $111, you know, that's a whole nother gift or two that you could get, right? So I think it's worth it. I would have done it. Okay. So what I'd like you guys to do is I want you to hit pause only for exercise 1 now. I want you guys to give exercise 1 a try. It's a lot like what I just did with the Black Friday problem. Okay, so hit pause for just this one, and when you're done, go ahead and see if you have the same answer as me. All right, so you go to buy these bracelets, right? And you have 25% off. So 1 minus the 0.25 is going to be 0.75 times 44, so it's $33. Well, now you also receive an additional 5%, so 1 minus 0.05, remember it's 5%, not 50, and you get $31.35 because I multiplied it by that 33. Okay, then to know how much I saved, I just subtract, right? So when you're at Kohl's, they're like, oh, look, you saved, and then they circle $12.65, and they're like, oh, look how much money you saved. And you're like, oh, okay, thanks, right? Okay, so let's take a look at number 2. We're going to do this one together. A golf store purchases a set of clubs at a wholesale price, right? So this is how much they're paying to have it brought to their store before it even gets on the floor of the store. Okay, Mr. Enman learned that the clubs were marked up by 200%. Wow, that's high. Okay, is it possible to have a percent increase greater than 200? Well, yeah, it is, totally. It is, you know, they do that all the time. Okay, so really when you think of a 200% increase, 200%, remember percent means out of 100, so technically this is really 2, right? This is really 2. Now remember also, markup means you're going to take 1 plus whatever that percent is, in this case 2. So technically, you're going to multiply your answer by 3. Wow. So let's figure out what the cost of these clubs are. The clubs are equal to that 3 that we just had right there times the price that they are paying for it, the wholesale price of $250. So when you walk into the golf store to buy a set of golf clubs, you're going to find that the clubs are actually going to cost $750. Okay, and yeah, that is kind of how the stores actually do it, and that's also how they can afford to give you a 50% or 75% off. They're still going to make money off of you. Okay, it's really crazy to think about it. If you ever go work in retail, you guys will totally see this working. All right, let's go over to the next page. Still working on that same idea. Is a percent increase of a set of golf clubs from $250 to $750 the same as a markup rate of 200%? So let's figure this out. So we actually have our whole. We have the part or quantity, however you want to look at it, and we are trying to figure out if that is the same percent increase as 200. Okay, so we're going to set this up as 750 is equal to the percent, which we don't know, times 250. So if I divide by 250 to find the percent, I get 3. 3 is equal to the percent. Now remember, we're talking about a markup, right? Markup, remember I said, is 1 plus that percent. Okay, so let's take a look at what's going on here. 1 plus something is going to equal 3. Well, what does that something have to be? And you guys are so smart, you already know the answer is 2. Let's change 2 to a percent. 2 as a percent is 200%. So is this the same? Yes. They are the same. Crazy, huh? All right, let's see what we have here on page 56 now. Still working here. Working backwards, okay? So we're going to work backwards and figure out what's going on here. So a car that normally sells for $20,000 is on sale for $16,000, right? And the sales tax is 7.5%. What is the whole quantity of this problem, right? What's the whole? Well, the whole in this problem is actually $20,000, right? That was the original price. What is my discount rate? It doesn't say how much are you paying now or how much did you save. I want to know the discount rate, so I'm asking you to find me a percent. So if 20,000 is the whole, that means that 16,000 is the quantity or the part, right? This was the whole. So we can actually plug this in and figure out what's going on. So 16,000 is equal to the percent, which I'm trying to find, times the whole, which we know is 20,000. So if I divide everything by 20,000, and don't freak out that there's these kind of big numbers, because look, the zeros all cancel out, and you really, and you really end up with 16 over 20. 16 divided by 20, that's easy. I can do that. That's 4/5. So my percent is equal to 4/5, which I know is 0.8, which is 80%. You are paying 80%. I want to know how much I'm getting discounted. So I'm going to take that and subtract from 100. So I have a 20% discount. Okay, that is the answer to that one there. 20% discount. Okay, so now, by law, sales tax has to be applied after the discount. Okay, but I'm curious, does it really matter when they take and put the percent on? Is it better for us, the consumer, to have them do it that way, or would it be better for us to actually have them do it at the end? Okay, at the beginning or at the end? So we're going to figure this out. So I'm actually going to take the tax first and do the discount second. Okay, now to get tax, remember this tax is 7.5%, which means it's 0.075, but this is tax, remember, is a markup. Tax is a markup, so this really is going to become 1.075. I'm going to have to add 1 to it. Oh, I hit something on the computer. I apologize for that. Here we go. So 1.075 times the original sale price, which we know was 20,000. All right, and I am going to now have to pay 21,500, but I'm going to take a discount. Okay, now remember the discount is 20%, or I'm going to pay 80%. So let's take the 21,500 and multiply it by the 80%, or 0.8, that I'm going to have to pay. And I find out that the car is really going to cost me $17,200. Okay, if I have to pay the tax first and then take the discount. Well, let's suppose we actually follow what the law says and we take the discount first. and pay the tax second. Well, I already know that I'm paying $16,000 for the car, right? They told me that. I've already figured that part out. And I'm now going to multiply it by just the sales tax, which I know is 1.075. And when I calculate that, I find out I have to pay $17,200. So even though the state law says I have to do it that second way, does it even matter? No, it doesn't matter. You can do it either way. All right. All righty. Let's take a look at exercise 4 across the page. Exercise 4, write an equation to determine the selling price in dollars P on an item that is originally priced S dollars. We're asking you to write an equation, you guys. All right. So selling price P, don't know what it is. We're literally going to call it P. We know that the selling price P is equal to the original price, which is S, and we're going to do a markup of 25%. So a markup is 1 plus that value, in this case 0.25, and times our S, which is our selling price. All right, so in other words, my price is going to equal 1.25 S, right? So that's an equation. No matter what selling price I have, if I know I'm just going to mark it up 25%, everything in my store I mark up 25%, I can then just use this equation to figure out my new selling price. So using that equation, let's make a table, all right, of different values. I'm going to use S for my selling price and obviously P for my new price, right? So I buy my item for, and I'm going to make my life easy, guys. Let's make this easy. Let's use values of 10. Let's go 10, 20, 30, 40, 50. I'm trying to make my life easy here. So I'm just going to multiply all those by 1.25. So my new price, I bought it for 10. I'm now going to sell it and put $12.50 on it. I bought it for 20. I put a price tag on it for 25. I bought it for 30. The price tag now says $37.50. I bought it for 40. The price tag says 50. I buy it for 50. My price tag is going to say $62.50. Just multiplied every single one of those by 1.25. Okay. Now what we're going to do, we're going to take all that information and we're going to graph it. So if I were you, I would pause it right now so you guys can see this screen here in that table and then make the graph on the next page because you're going to be flipping back and forth and back and forth. I am going to get it set up here. All right, here we go. So I'm going to put the original price down on the bottom. Okay. That's what we called S. And we're going to put our new price up here on the y-axis. That's what we called P. And let's think about what we counted by. I counted by 0, and then 10, 20, 30, 40, 50, right? If you want, you could put 1 on every line. I just spread it out just to, hey, spread it out. Now think about what our values were doing on that new price. Was it going at a constant rate? Yes, it was. So let's make life easy. Let's count by those as well. $12.50. Now, if they didn't go at the constant rate, then you wouldn't be able to do this. But because those numbers are going at a constant rate, we can. Makes life easy for us. 50 and what, 62? Did I skip one? Nope. 62.50. All right, now we're going to graph those. So we'll put a dot at 0, 0, because, hey, it's still going to be there. 10 was $12.50, 12 was 20, or excuse me, 20 was 25, 30 was $37.50, 40 was 50, 50 was $62.50. Look at that. All right, let's review way back in book number 2. Okay, we want to interpret the point 0, 0 on this graph. Okay, now the original price was free and the new price is free. So even after I do the markup, a free item is still a free item, right? That's literally what I'm going to say. A free item is a free item. Didn't change its price at all. What about the 0.1 comma R? And you're like, well, what in the world are we talking about? If I bought something that was $1, right? It was $1. How much is it going to cost me over here? Well, if I put 1 into there, right, into that equation, it would become 1 and 1.25. So in other words, a $1 item is now $1.25. That's what that means, right? I marked it up that way. I'm going to ask you one more question. Is this proportional? Let's go way back. Is this a proportional relationship? Oh, can we remember? It is proportional. Do we remember why, though? Because two things that are going on in that graph. One, it makes a line. Right? It makes a line. And what's the second thing? It goes through, yep, that's right, 0, 0. Those are the two reasons I know that that's proportional. All right, last time, look at exercise 5. Use the following table to calculate the markup or markdown rate. Show your work. Is the relationship between the original price and the selling price proportional or not, and explain. So what we're going to do is we're going to figure out if our selling price, P, divided by the original price, M, if that gives me a same rate that I'm going to get every time. Okay, so I'm going to take 1,400 and I'm going to divide it by 1,750, and I find out that I get an answer of 0.8. Well, let's do the same thing again. Let's take our 1,200 and divide by 1,500. Grab your calculator. What do you get? 0.8. Yep. All right, let's try one more. Let's take 1,000 and let's divide that by 1,250. And what is my markup rate? 0.8. So, is this proportional? Yes. How do I know it's proportional? What do you notice right over here? I have a constant rate, right? This is proportional because there is a constant rate, right? That's constant. All right, we will do the summary when you guys come to class. Sorry, this one was a little long for you guys. See you all later.